Today we are going to talk about implicit conversion in Python. So if you have an int here and you have a float, when you add them together, the result that you get will be a float. This is because Python converts the lower precision number, so int, to a higher precision. Because the precision of a float is higher, it will convert to that data type. So you will get a float at the end. Now, if you want to do explicit conversion, such as you want the number to be an int, you can use the int function here, which will add the two numbers together and it will chop away the decimal part. So the decimal part will just be chopped away. Remember, it won't be rounded as such. It'll be just chopped away. So if I run this, and as you can see, we've got a result of 12.5, and that is of data type float. And then the second result we have is just 12, and this one is of data type 2. So that's result 2. So yeah, just remember this around implicit conversion in Python, and you can explicitly convert if you want. But by using the int function, it will chop off the decimal part, or you will just simply end up with the integer part. In Python, you can use explicit data type conversion functions. So here, I'm using an int function to convert a float. So what this will do is it won't round the number. Instead, it will simply truncate the decimal part. Then I'm using a float function to convert string into a float. I am then using a string function to convert an int into a string. And then I'm using a list to convert a string into individual characters. The last one will be really useful if you want to manipulate individual characters. So if I run this, and as you can see, the 5 here, the 5.9 here, and that is being truncated. Then you have a float. This is a string. So imagine this coming in from a user input. We can convert it into a float by using a float function. And then we have 1, 2, 3, which is int, and that's being converted into a string. And that can be used by the print function. And then you've got a list, which is this string broken up into individual characters, which you can then manipulate. So just remember these explicit data type conversion functions in Python to convert your data type to a specific explicit type. There are many ways to assign variables in Python. You can assign single variables like this: x equals 10, y equals 5.5. You don't have to declare a data type, or you can do it as a way of a calculation. So here, z is equal to x plus y, which are the variables declared earlier. Or you can declare multiple variables and then assign them multiple values. So here, these values correspond to the position of the variable. So a, b, c, and 1, 2, 3. So they'll get assigned accordingly in that order. Or you can say x is equal to y equals to z, and that is equal to 100. So here 100 will go into z will then go into y because it's 100, and then y will go into x, which is also 100. So you will get an output like this. If I run this, as you can see, we've got the output here. And for this one, where we're declaring multiple variables, we are getting the values printed according to how we assign them in the same order. And you can see here, this one is 100, 100, and 100. So this matches our assignment here. So just remember these different ways of assigning variables in Python: single at the calculation, multiple declarations and then assignment, or one variable equal to another, or declared on the same line, and the final value is the one that gets replicated to all variables. It's important to understand dynamic typing in Python. Python is not a strictly typed language. So when you have a variable core data here and you assign it an integer, and then you try and work out what type of data it will hold, then Python will say that variable is of type int. But then you use the same variable and then you give it a different type of data, such as a string, it will happily accept it, even though originally it was an int data type, or then it will change itself to a string data type. So this is important to note about Python, that it does that. The other thing that you can do is swapping variables without creating a temporary variable. So here you have one variable which has the value of 5 and b has 10. And you want A to have 10 and B to have 5, so swap them around. Normally, you would create another temporary variable to hold the values while you do the swapping around. But what you can do is you can swap two variables together by putting A here, B there with a comma, and then equal sign, and then reverse the order. So you want A to have B's value, and you want B to have A's value. So you just put them in the other way around. And then you will suddenly find that A now has the value of 10 and B has the value of 5. Now, if I were to run this, and so you can see the output or here, as you can see, when we had the data type, we had class of int. Then when we changed it to a string, suddenly the same variable has changed to a string. And here you have 10 and 5. So here, yes, you can swap a variable without actually declaring a temporary variable. They've just been swapped around by using this. So A comma B then equal to B comma A. So this is how you swap the variables. In Python, there's a special keyword called pass. The pass is a keyword that you can use and you don't want your code to do anything. For example, let's say I have a class and I'm not ready to define that class yet. I just want a skeleton of that class. So here you can use pass, and what it will do is that class will still work, but it will be valid code, but it won't do anything. Or you can use it, for example, if you've got some try statement for error handling, and when you get, for example, value error, but you don't want to do anything, you can just add the word pass, and this would be valid code. Now, if you of course got something like this, like a loop, and you're not sure whether you want to do anything at this point for number 2, then you can include the word pass. Now, if you comment out the word pass, of course, what you will get is it says it's invalid code and you're going to get an error. So by including the word pass, the pass will actually not do anything at all, but it just makes the Python code valid. And here again, so if you've got a function here and you don't want the function to do anything yet, but you will implement it later, so you can just add the word pass. Now again, if you don't do this, then of course, what will happen is it will say it's syntax error, though you can just add the word pass to make your code valid, and that will mean that your code will work. So here, as you can see, this code will work and you get the output here. There you go. So you can see the output here, all this code just by using the word pass. Whereas if you don't include the word pass, and if I comment out, for example, this one, then try and run the code. If I run this again, and you can see now I've got an error. The pass just makes the code valid. So remember to use pass when you don't want the code to do anything, or you're not sure how to implement, for example, a function, a class, or even in a loop. You don't know what you're going to do with this value yet. You're waiting on some requirements. Then you can use the word pass. So in my previous video, I talked about the statement pass. You can use it as a placeholder when you want to not do anything, or you want to implement something in the future. But then somebody commented and said, well, what about the ellipses? So when should you use ellipses? So the 3 dots, which are known as ellipses, you can use for the same purpose as you would use pass, but there are slightly different variations to it. So by using ellipses, you are definitely saying that there's something to be implemented here, but you want to do some implementation in the future in here. It does have the same effect as the statement pass. So this is more of an expression. So this is a statement while this is an expression. So while this could be left in a class and you definitely, for example, don't want to do anything, but it can act as a placeholder. So the ellipses is definitely, I think, you should use it in a situation where you want to implement something but haven't got around to it. While pass, generally, you could go with the idea that actually I don't want to do anything here, so I just pass. Don't want to do anything, do nothing. But remember, ellipses has a different meaning. So again, you can use it in the same places. So here I'm using in a class, a method, a function. Ellipses has a different purpose as well, which can be confusing, I suppose. So you can see the ellipses here, we're using it within slicing an array. So here, what we are trying to do is this array, what we want to do is select all the rows. So this will indicate select all the rows, column 2. Remember, Python is 0-based array, so 1 actually is the second column. So that's the difference between using an ellipses versus pass. It's up to you really, to be honest, but I would avoid using ellipses because it can be confusing because of its multi-use. But pass has been in Python for a long time, and it's quite clear what you're trying to do here. But I suppose if you are, indicating that I'm definitely going to implement something here, then you can use ellipses. So I hope you got the difference clear in your head. I would stick with pass in most instances where you need ellipses that be used, but remember, it can cause confusion, and I suppose it's not that easy to understand. Actually, that's something that's been forgotten to implement here. Somebody not aware of the slicing, they could easily get confused. So while pass is a clear indicator that you don't want to do anything, or you intend to implement something in the future, but don't really want to do anything. So I hope this makes a difference. But as you can see, this code, ellipses makes the code valid, and so does pass. Slicing in Python is very important to understand. Here's how you would slice a list. We have the following elements in a list and we want to slice them. This is how you slice, and this is the sort of the syntax for it. So you key a start and then a colon and then stop and then step. Again, all these are separated by a colon, as you can see. So let's take a look at this example. So we need to slice this data or split out or extract this item from the list. So what you do is you say from first element to the fourth. Now the fourth element is exclusive. What it will do is it will stop before it. So it won't actually do the fourth element. It'll be up to sort of the third element. Here you can see index 1. So this is, remember, Python lists are 0 index based. So you see here, this is 0, this is 1, this is 2, this is 3, and this is the fourth. Now the output that you will get is up to only 1, 2, 3. So if I run this, you can see that we only got the output here of 1, 2, and 3. So let's look at the next one. So here we've got up to start from the beginning and up to the third. So here we can see 0, 1, 2, 3. So this is exclusive again. So you don't include this third element. So you only go up to 0, 1, 2. And as you can see in the output, that's what we get. And that's what I said here in the comment. So here, let's look at this one. So here we've got index starting from 2 to the end. So again, if you look at the elements, so this is 0, this is 1, this is 2. So from the 2, second element, all the way to the end, which is the fifth. So notice that you can leave this blank. So all these parameters are optional to supply into the slicing. So here, then you can see I've said print the entire list. So you don't basically supply any value. Then here's the one with the step. The step, why we're doing is, so the entire list, because we left this blank and this blank, you want to step every second element. But you start at the first one, which is that 0, and then you go 2 steps. So it'll be 1, 2, and then split 1, 2. And because the 5th and 6th element don't exist, it would basically stop at there. So it'll give you 0, 2, 4. And this is the output that you can see here. Now, the reason you might be thinking is why the exclusive part. The exclusive part is due to why not the 4th element. So when we say 1 to 4, why should it not do that? Oh, 0, 1, 2, 3, 4. So it should include the 4. The reason is Python tries to be consistent. So here I've got the range function, and the range function you say 1 to 4. But what it will actually do is it will print from 1, 2, and that's it. It will stop there. So the exclusive part comes from being consistent in Python. If you see the output for the range here, you only get elements 1, 2, 3, 4, even though you said 4 in here. So it's always -1. That's the way you need to think of it. And unfortunately, that's the way it is. So you just need to kind of remember this part of it. So yeah, just remember, this is the syntax. So start, stop, step. Remember, all these are optional, but you can pick and choose what you want and what is it that you want to extract. You can do pretty creative stuff with this sort of stuff. This syntax here. Did you know in Python, you can reverse a list or words using the slicing syntax? So this is how the slicing syntax works. So you have a variable, and what you do is in the square bracket, you provide a start index, stop index, and a step. You can leave the start, stop, or step. All these are optional parameters. So here, for example, I have a list of numbers and I want to reverse them. So what you can do is these parameters are optional in the syntax. You supply nothing there, separated by a colon. And for the step variable, you do a minus. So what you want to do is you want to go one step at a time in reverse. So what that would do is it would put the order like this. And then you can use this technique for other things such as strings. So here, where you've got my string, again, we want to print out the word hello. So what you do is the start is you start at 0. So if you don't give it any value, the default will be able to start at the beginning. And then you want it to stop at 5. And you might be wondering that the 5 is actually a comma. So what the syntax, how it works is it always does a -1. So here, you only get the word printed off to hello. So the next one is slice the word word. So this is the 7th character, and I will go all the way up to 12. So you can see this is the 12th character, but we always ignore that one. So it's -1, and then you have the word printed word. And then you can see here, you can now use that technique that we showed about reversing a list to reverse the string. So here, the string variable is now being reversed. So everything is being printed in reverse. So remember the syntax, it's start, stop, step, and then you can put negative number in the step to reverse the order of things. If you put positive number in, of course, it's just going to step by that. Now you don't have to put -1, you could put -2, and what it will do is it will step over that in reverse. So if I run this just now to show you how that works, so you can see the list of numbers have been reversed, and you can see hello word being printed and also hello word being printed in reverse.